Okay, welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.4, day 2, entitled Rational Expressions. And yesterday we talked about domain and simplifying rational expressions. So today we're going to talk about the next two objectives there, multiplying and dividing, and then adding and subtracting rational expressions. Now when we multiply rational expressions, it's just like multiplying fractions. When you multiply fractions, you multiply straight across the numerator and straight across the denominator. So we're going to do that too, except the only thing we're going to do first is we're going to factor. So we have to factor any numerator or denominator that we can so that it's as simplified as it can get. That way, if we can cancel some stuff before we multiply, if we can do some cross canceling, that's going to be beneficial to us so that we have more simplified expressions that we're multiplying together. So in my first fraction here, I have a trinomial over a trinomial, so I'm going to factor both of those with guess and check. So I'm going to start in my numerator, and I need the factors of 3. That'll get me to 2. So I'm going to need an x and an x, and then the factors of 3 are going to be 3 and 1. And then I need the factors to add up to a positive 2, so I need a positive 3 and a negative 1. And that way they'll also multiply to the negative 3. In my denominator now, I need the factors of 16 that are going to get me to an 8. So I need my x and my x to get my x squared. And then I need the factors of 16 that'll get me to an 8. So that'd be a 4 and a 4. If I make both of them positive, they'll add to an 8 and they'll multiply to a 16. And then in my second fraction, I have a binomial over binomial, and that binomial in the numerator, I can take a GCF out of there. So don't forget that that is a way to factor as well, just by taking out the GCF. So that'll get me a 3 times x plus 4. And then in my denominator, I can't do anything, so I'm just going to leave him x minus 1. Now, again, remember, I said that the reason that we do this factoring first is so that we can cross-cancel. And cross-canceling can just be anything from the numerator to the denominator. So in my numerator here, I have an x minus 1, and in my denominator over there, I have an x minus 1. So they're gone. In my numerator on the right side, I have an x plus 4. My denominator on the left, I have 2 x plus 4s actually. I just cancel out one of them. Either one, doesn't matter. And that's all that I can cancel. So now I'm just multiplying 3 times x plus 3 in my numerator. Just rewriting the order a little bit. Remember, you can multiply in any order. And now in my denominator, all I have is that x plus 4. Now, leaving your answer like that is completely acceptable. However, your book might multiply it out. So it looks like 3x plus 9 over x plus 4. So either way you write that is acceptable. And remember, we also will see those limitations in our answers. So it'll have the domain, the restrictions for the domain. So here, my domain, I couldn't have any value being equal to 4, because if I had an x value of 4, that would make my denominator 0. So I'm going to say my domain is going to be all the x values such that x is not equal to 4. So you might see that restriction on your answer as well when you look in the back of your book. Now when we divide rational expressions, remember we never actually divide them. We never divide fractions. We always multiply by the reciprocal. Remember I call that my butter. Okay? Now we're still going to factor. And then we're going to multiply by the reciprocal so that hopefully we can cancel out some like terms from numerator to denominator. So in my first fraction, I have a binomial over binomial. The binomial, my numerator, I can't do anything to him to simplify him, so I'm just going to leave him x minus 4. My denominator, though, is a difference of 2 squares. So that'll be x plus 2 times x minus 2. Now I'm going to do 2 steps in 1 here for this next little fraction. I have a trinomial over trinomial, so that means I'm going to try and do guess and check. and I'm going to change the division to multiplication, so I'm getting ready to multiply by the reciprocal, and I'm going to multiply and then write the reciprocal as well. So I'm going to factor this denominator and then write it in my numerator. So I'm really doing 2 steps in one here. Okay, so my denominator is going to move up to the top, so that's the factors of 6. It'll add up to 5. Now 6 is tricky because 6 has factors of 2 and 3 that could get you to 5, and 1 and 6 that could get you to 5. So you have to think, you have to take a moment and be smarter than the problem. You have to think which combination is going to get me to 5, but also have these same signs. I need a plus and a plus. So I need a +2 and a +3, because those will add to 5 and multiply to a +6. Okay, so that was my denominator that I factored and moved it to the numerator. Now I'm going to factor my numerator and move it down to my denominator. So I need the factors of 4 that are going to add up to 3, or -3. So I'm going to have an x and an x. And the factors of 4 that are going to add up to 3 are going to be a 4 and a 1. And I need it to be a -3, so I need the 4 to be negative and the 1 to be positive. So now that I have my problem factored and I have it rewritten as multiplying by the reciprocal, I'm going to try and cancel. And I see that I have an x minus 4 in the numerator and an x minus 4 in the denominator. So those whole terms, that whole binomial, is going to cancel from top to bottom. I also have an x plus 2 that I can cancel from top to bottom. And that's it. That's all I can cancel. So now if I multiply across the top, I just have the x plus 3. And if I multiply across the bottom, I'm going to have the x minus 2 times the x plus 1. And you can leave your answer like that. Your book will even leave it like that as well. You don't have to FOIL or multiply out the denominator. You can leave it as 2 binomials multiplied together. However, you might also see that condition for the denominator, or for the domain. So you might need to say that this answer exists when all the x values are, let's see, not equal to 2 and not equal to -1. Those would be the 2 values that would make my denominator 0. Now we have 3 examples left, and these last 3 are going to be about adding and subtracting rational expressions. And these are more time consuming, a little more tedious. You really have to pay attention to your work here, because when you're adding and subtracting rational expressions, you have to have a common denominator, just like when you're adding regular fractions. And it's a little more tedious now because these denominators are going to be monomials or binomials or trinomials. So we might have to factor the denominators down to see their little pieces, and we have to make sure that each piece of each part of the addition or subtraction is represented in our new denominator. So example 5 here is going to have an A and a B on this slide, and then we have part C on the next slide. And A is pretty nice. It's pretty straightforward. We have 3 over x minus 1 plus x over x plus 2. And these 2 denominators cannot be factored anymore. They're already as simplified as they can get. So think of it kind of like having a fraction where you have 3 over x and then x over y. You would need an x and a y as your new denominator. So here I have an x minus 1 as a term and an x plus 2 as a term. So to make my new denominator, I need both of them. And I like to rewrite my new denominators first for each part of the problem before I start actually going through and manipulating the problem. So basically what I've done here is I've taken this first fraction, this first denominator, and I've multiplied it by x plus 2. I've made it x plus 2 times bigger. So what I did to the denominator, I have to do the numerator. So I have to take that 3 and multiply it by an x plus 2. Don't cancel. A lot of times students want to cancel here. They see the x plus 2 and the x plus 2. We got just done adding, or we just got done multiplying and dividing, where we talked about canceling, but we're not doing that here. Okay? We want to get one simplified expression, and if we cancel out that x plus 2 and x plus 2, we're just going back up to our original problem again. Now in the second fraction, I had the x plus 2 already in the denominator, and I multiplied it by an x minus 1. So I made the whole fraction x minus 1 times bigger. So I have to multiply that in my numerator as well. And again, don't cancel. Don't cancel the x minus 1 and the x minus 1. I know they're the same, but we want them to be the same. We're trying to make these fractions bigger, okay? When we're multiplying and dividing, we're trying to make things smaller. But here, when we're adding and subtracting, they're going to get bigger. Now I'm going to do this next step, since I'm kind of short on room, I'm going to kind of do it without writing out the denominator. But basically what we have to do now is we have to simplify our numerator. We have to distribute the 3, and then we have to distribute the x, so we can combine our like terms. So I'm going to get a 3x plus 6, and then I'll have an x squared minus x. And technically that would be all over our new common denominator, but I'm just going to leave that out now so I don't run out of room here. So now if I combine my like terms in my numerator, I would have the x squared first, and then the 3x minus x would be a 2x, and then the plus 6. And again, that's all over my new common denominator. And you can leave the common denominator in its little factored pieces like that. You don't have to multiply it out. Now, before you walk away, though, you want to make sure that you can't factor this numerator and cancel now. Now that you have one big fraction, if we could cancel, or if we could factor the numerator to cancel any of these terms in the denominator, then we could do that. But if we factor the top, we won't have anything that will cancel, so we're done. We're good. That's our answer there. And again, you might have those restrictions on your denominator, and just to save space, I'm not going to write out the whole set notation, but we wouldn't want x to be 1, and we wouldn't want x to be -2 here. Those would be the restrictions on our denominator, or that would be our domain, all the x's such that x is not equal to 1 and x is not equal to -2. Okay, now for part B, this is a little bit trickier. I'm going to kick it up a notch because we have to actually factor our denominators. This first one is an x squared minus 1. That's our first denominator there, and it's a difference of 2 squares. So this is really an x plus 1 and an x minus 1. Okay, so I'm just going to kind of rewrite the denominator. Now our second denominator is an x plus 1 squared. I don't really have to factor it, but I'm just going to rewrite it as x plus 1 times x plus 1. So that way I don't forget that there's 2 of them there. So now if we're trying to find our new common denominator, you should be thinking, hey, wait a second, if I look at these denominators, they have something in common. They have an x plus 1 and an x plus 1. They have that in common. So I'm going to need one x plus 1 in my new denominator for sure. And then I also need the other little pieces that they don't have in common. So I need that x minus 1 from the first denominator and that other x plus 1 from the second denominator. And again, you can write these little pieces in any order. You can write these little binomials in any order. I wouldn't write it as x plus 1 squared, though. Just leave them separate as x plus 1 and x plus 1, because that's going to make this next step more simplified for you. In my original fraction here, this denominator had an x plus 1 and an x minus 1. Now, if I compare that to my new denominator, I still have the x plus 1 and the x minus 1. I also have this other x plus 1. So I made that first fraction x plus 1 times bigger. So that's what I have to multiply by in my numerator. I made that whole original fraction x plus 1 times bigger by finding a new common denominator. We're going to do that same process for the second fraction. Originally, I had an x plus 1 and an x plus 1. So I had the two x plus 1s already, but this x minus 1, that's the new piece from the original to the new denominator. So I made that fraction x minus 1 times bigger, so I'm going to make my numerator x minus 1 times bigger. Now, like we did before, we're going to distribute here. So if I distribute the 1, I'll just get 1x plus 1. And there's a couple ways that you could think of this next step. You could think of it as subtracting everything after you distribute the 2, or you could think of it like adding a -2 and distributing the -2 to everything. So it's personal preference, but you need to make sure that you distribute and you change your signs. So you end up with a -2x, and then a negative and a negative gives you a +2 after you distribute the 2 to the 1. So that would be my numerator. That would be all the terms in my numerator. And again, that would be all over our common denominator. I'm running out of room here, so I'm not going to write in the denominator. But I am going to go ahead and combine my like terms in my numerator here. I have x minus 2x, so that's -x. And then I would have my plus 3. And then again, this would be all over my common denominator. So now, since I have my fraction all simplified, I can combine those two binomials that are alike in my denominator and write x plus 1 squared to save space. And again, before you just box this and walk away, you want to say, okay, now that I have one big fraction, is there anything that I could simplify, anything that I could divide out and reduce it down? But in this case, no, there's not. There's not anything that we could cancel to reduce. So that's our answer. But again, we have to remember those restrictions on our domain. We would have all the values of x such that x is not equal to 1 or x is not equal to -1. Okay, last one. This one's pretty tough because we have 3 terms, but it's the same steps. We're going to see if our denominators can be factored at all. Then we're going to find our new denominator that incorporates all the pieces. And then we're going to adjust our numerators. So this first denominator is x squared minus x minus 6. That's a trinomial, so we'll be able to factor that with guess and check. And there are factors of 6 that are going to add up to a -1. So that would be a -3 and a +2. So really that trinomial, I'm just going to think of it as these two little binomials being multiplied together. Now the other two denominators, I can't do anything to them. They're already simplified, the x plus 2 and the x minus 3. They're already as simplified as they're going to get. And the nice thing is that 2 of my denominators have an x minus 3 in them, and 2 of my denominators have an x plus 2 in them. So now that we have this problem factored, seeing the common denominator is actually fairly straightforward. It kind of just jumps out at you. We're going to need that x minus 3, and we're going to need an x plus 2. Those are the two little pieces that are present in every denominator. Okay, so there's my 3 new denominators. Now this first fraction, I didn't do anything to it. I still have the x minus 3 and the x plus 2 as my denominator, so I didn't make it any bigger. I just multiplied it by 1. Okay? The second fraction, though, it had the x plus 2, but I multiplied it by the x minus 3. So I made it x minus 3 times bigger. So that's what I have to multiply by in my numerator to adjust. In the the last fraction, I had the x minus 3, but I multiplied by the x plus 2. So I made it x plus 2 times bigger. So again, that's what I need to multiply by to adjust my numerator. And again, don't cancel. I know there's an x minus 3 and an x minus 3 in the second fraction, and an x plus 2 and an x plus 2 in this third fraction, but don't cancel them. Can't cancel until we have one big, giant fraction. So again, I'm going to distribute here. I'm going to distribute the 1. You could think of it as distributing a 1 and then subtracting, or think of it as adding a -1 and you're distributing the -1. Same thing here for the 2. We're subtracting. So if you distribute the 2, remember you got to subtract both of those terms, or think of it like adding and then distributing a -2 to both of those terms. So my numerator is going to be x minus x plus 3 minus 2x minus 4 when I distribute. And again, I'm not going to write the denominator just because I'm kind of smooshed for room here. But if I combine all my like terms, let's see, this x and this x, they cancel. So I just have the -2x, and then the 3 minus 4, that would be a -1 over the x plus 2 times the x minus 3. Again, you don't have to distribute or FOIL out the denominator. You can leave it as the two little binomials multiplied together. And I won't be able to simplify from there. Now that I have one big fraction, I won't be able to simplify. Nothing on the top is exactly the same as the bottom. So we're done. You might also see those restrictions on your denominator. Remember, this fraction or this expression doesn't exist when x is equal to 3 or when x is equal to -2. So those would be the limits in your domain. You'd say my domain is all x's such that x is not equal to 3 and x is not equal to -2. Okay, so there is your set of practice problems. Good luck, do well, and if you have any questions, come see me before school.